Okay, so now we're going to look at the situation when that power is -1, which, it is a very different situation. Now, to start off with, we'll just do a nice one. So anti-differentiate x to the -1. First thing we need to know is that x to the -1 is the same as 1 over x. Now you might recognize that from when you were doing differentiation and you did the derivative of a particular function, which was the log function. When you did that, you got 1 over x. So remembering that it was the derivative of the inner function here divided by that function itself. That was the answer. So when we anti-differentiate this here, okay, we're doing the antiderivative of 1 over x with respect to x. We're going to go back to having this. So that is just log e of x and then plus c. I'm going to add in one other little feature here, and that is that I'm going to make it so it is the modulus of x. Okay, there is a very good reason for doing that, and that's because the log function will behave differently depending on what is actually inside here, and it can get quite messy if we don't include those modulus signs. So I'd suggest that it's best to just make sure they're included every time you answer one of these questions, and should be all good. So that's what we end up with there. Find the general antiderivative of this. So the antiderivative of 2 over 2x minus 5 dx is equal to, now what I'm doing in a question like this is I'm looking and I'm seeing that this number here is the derivative of this here, so straight away I know that it's going to be a log when I anti-differentiate it. And so this one here just comes out to be the natural log of 2x minus 5 plus c. Remember that the number or the value or the function in the denominator is always going to be the inner function. Well, that was a pretty quick and easy question. Let's skip on. A little bit more complicated this time. Okay, this is a pretty extreme example. So find y in terms of x if dy dx equals all that mess, and y equals log e of 5 plus 2 when x equals 0. So what I'm going to do here, again, I'm looking at this and I'm seeing right away that the numerator is the derivative of the denominator. Now, as I said, this is a really extreme example, and I probably wouldn't expect to see too many questions like this in methods, but I'm doing this just to highlight how it sort of works. So we again know that y is equal to the antiderivative of dy dx with respect to x, which in this case is the antiderivative of 2x plus 3 over x squared plus 3x plus 5 with respect to x. So again, as I said, that there is the derivative of the denominator. So that just comes out to be, oh, just give me a second, I just want to check something. Oh yeah, gee, I was a little bit slack with that last question. Sorry, I'm just going to go a little bit off topic here, but that there should be the modulus of 2x minus 5. Anyway, so when I do this question, I'm going to get log e, and I'll remember at this time the modulus of x squared plus 3x plus 5, and then plus c. Now, we know that when x equals 0, y equals log e of 5 plus 2. So log e of 5 plus 2 is equal to log e of the modulus of, well, 0 plus 5, which is just 5, and then plus c. Well, the modulus of 5 is just 5, so we've got ln of 5 plus 2 equals ln of 5 plus c, and so by comparison we can right away see that c is equal to 2, and therefore y equals log e of the modulus of x squared plus 3x plus 5 and then plus 2.